Think of this.
So it can go around the back of your head? Yes. And then hook it on your ears?
If you put it under your ears, it'll stay.
You're going to be the newscaster. Yes. It's turned up all the way, I'm not sure.
This better? Yeah. Okay. Yay.
I need you to take my McDonald's order now, please.
Where's Marilee? She's not here this year, right?
No.
What's up with her? It's not her fault that I'm up here. So, like, it's a little bit rude of her to not come. We gotta get all this stuff.
Hillary? It's just the water. You know, it's louder. Maybe it's louder if the speaker turned up all the way or something.
Ask Kirsten, she's like,
I do my best to talk loud. I'm not good at loud, so I try.
maybe we can turn on the video just for your talk. Yeah, because that's good. It's all the way up. So you also just have to bring the microphone. It is all the way up.
Okay. That's a big difference. Nice. Okay, so last year I was talking with Marilee and just getting to know her a little bit, and she asked me, like, what do you do and stuff? I'm like, well, I studied physics, and she asked me if I thought that that was a spiritual discipline, and I had to think about that for a little minute. And the image that came to my mind was this one right here. I was analyzing this with my graduate advisor. This is a cross-section of a gallium nitride nanowire. Of course it is. So this little line is 20 nanometers right here. And we were looking at this and analyzing it. It has multiple types of crystal. So gallium nitride the crystals can form in different ways. It can be hexagonally shaped, or it can be cubic. And this tiny little nanowire has multiple, some of it's hexagonal and some of it's cubic, and it's all smushed together. And it's not particularly pretty at the boundaries between it, but it managed to all grow together, even though this part and this part, it's the same type of crystal, but it's in different directions. But it was still making one thing. And as we were analyzing this, there was just a sense of wonder and awe that it even existed. So I was able to tell Marilee that, yes, I think physics is a spiritual discipline. And I hadn't really ever made that connection before. I find it wonderful and amazing and awe-inspiring that we figure, on all the clever ways that humans take advantage of knowledge. That's just a marvel to me. So I chose to study physics because I like to start at the beginning of things. I knew that physics was the basis for chemistry, and chemistry was the basis for biology. So if you were to order matter by size, it will go something like this. You've got your subatomic particles, you've got your atoms, your molecules, and your cells, and your organisms, your ecosystems, the whole Earth, and then bigger stuff like planets and stars and galaxies and all that kind of thing. And physicists typically study subatomic particles and atoms and that kind of stuff. Or planets and stars, and you've got astrophysics, so physics, and then in between you've got chemistry, microbiology, macrobiology, earth sciencey stuff, and then you're back to physics. So all of this stuff is really actually physics, okay? As far as I'm concerned. So it encompasses all of science. I did my undergrad in physics, and then I have a master's in electrical engineering, and then for both of those programs, I actually did research in material science. And one of the materials that I have experience studying is carbon. A familiar form of carbon is diamond. And this is why I made this little thing here. So if you have a diamond ring, it's made out of carbon atoms that are arranged like this. And the carbon atoms, so each of the carbon atoms that are in the middle of your diamond ring are bonded to 4 other carbon atoms. And these bonds are very, very strong, and they're equally strong in all the directions. That's what makes diamond the hardest natural material. Another familiar form of carbon is graphite. So graphite is the lead in your pencil is not made out of the atom lead, it's actually made out of carbon, it's graphite. And these carbon atoms are arranged in sheets of hexagons. And these hexagons, they are very strong bonds between them. So you've got one sheet of hexagons and another sheet of hexagons and another, and they're just layered on top of each other. The bonds between the sheets are not very strong. They're very slippery. And that's why you can use a pencil to make a mark on a piece of paper. Okay? So diamond and graphite are both made of the exact same thing. They're both made out of carbon atoms. They're just arranged in a different structure. And that structural difference is super important because it gives these two materials completely opposite properties. Diamond, hardest known material. Graphite, very soft and slippery. I was able to hold a chunk of graphite and it almost felt oily. It was that slippery. Diamond is very abrasive. It's used to drill and to polish. It makes rough surfaces smooth. Graphite is used as a lubricant. It helps rough surfaces to slide against each other more easily. So pretty much opposite properties here, even though they are made out of the exact same thing. So I'm going to make a kind of a silly analogy here. I'm going to say that you are a carbon atom, and you are going to behave differently when you are in a different spiritual structure or a different social structure. And this is my silly analogy. The church is like diamond. It looks pretty. It can be pretty hard to alter. The atoms on the surface of the diamond are in energetically unfavorable positions. So the atoms on the surface of the diamond might only be bonded to 2 other carbon atoms when they really want to be bonded to 4 other carbon atoms. So they're not very happy. They might twist the lattice structure of the diamond to make it a little bit more comfy for them. They might kind of skim along the surface to find a better place where they'll be happier. There might be a little ledge or something where they can bond to and be happier there. They might pop off for a little bit and come back on later if they find a more favorable energy position. Or they might just pop off and stay gone. Carbon atoms that are on the surface will also readily bond to other atoms like hydrogen or oxygen. And depending on what type of atom they bond to, that's going to affect the properties of the crystal. You might have a hydrophilic surface or a hydrophobic surface. You might have an insulating surface or a conducting surface. So you can engineer the surface of a diamond to have specific properties. So the analogy here, it is energetically unfavorable to be at the boundary of church. Some of us are engaged with church but feel discomfort. Some of us have found church engagement to be untenable for whatever mix of reasons. I want to suggest that you can engineer engineer your church relationship to meet your life's needs. And I also want to note that people that are at the boundaries of church have extra influence with how the church interacts with the outside world. And you can decide what that looks like for you. For me, pilgrimage is like graphite. It's at pilgrimage we get to experience what it feels like to be in a different spiritual structure. I always make new connections and new relationships, and my brain is flooded with new ideas. And I always feel so creatively energized after pilgrimage, which, like, a pencil is a great metaphor for creativity and learning, and I feel like that happens for me so much at pilgrimage. So graphite, to me, this works really well as a metaphor. Pilgrimage is a totally different experience than going to church for me. And it also helps me to communicate my spiritual experiences I'm able to communicate them in a different way than I am at church. Now, there are other forms of carbon other than just diamond and graphite. So this is diamond, this is graphite. There's something called fullerenes, which are ball-shaped things. Something you might have heard of buckyballs, that's a fullerene. You can also have multiple layers of balls, like a ball inside a ball inside a ball. Those are called carbon onions. Graphene is just one layer of graphite. And then something else that I studied was carbon nanotubes. And those come also in a bunch of varieties. So you can have a bunch of layers rolled up, or you can have just a single layer rolled up to make a tube. And there's a couple of different ways that these tubes can be rolled up. So you can roll it up straight, or it can be rolled kind of twisty. And that twist creates a different property than if your carbon nanotube is straight. They can be either semiconducting or conducting. So even just that small change of how your carbon, your graphite is rolled up, that affects the properties. For engineering, it's all about creating the correct properties for your desired application. Your end goal dictates your parameters. If your spiritual life isn't giving you the desired result, experiment with the structure. And remember that small changes can affect the properties. Now, carbon doesn't only bond with itself, it bonds with lots and lots and lots of other elements in a myriad of different structures. This is organic chemistry and biology, and I don't know very much about those things. They're complicated. This is the complicated middle stuff here. But we say that we have carbon-based life. And some science fiction authors try and imagine what it would be like to have a life form not carbon-based, and like we just don't even comprehend what that could really look like. Carbon is so essential to life as we know it. So this whole magical life, our bodies, our minds, our souls, our entire experience exists because the carbon atom bonds so readily with other elements. All right, I want to take a break from all the sciencey stuff for a little bit and talk about God as the creator of life. Several years ago, like maybe a decade or so ago, we read Joseph Campbell's The Power of Myth in book group, and one of the ideas that really stuck with me was he told about how early societies they tended to worship female deities, and they tended to envision her as being Mother Earth. So you've got this fertility goddess often in early societies. And then later societies tended to worship male deities and would imagine this male deity to have some separation between this father god. And often it's a son god who is just inconceivably far away. And when I encountered those ideas, I'm sitting there thinking, I want both. I think that these ideas are compatible. So the idea of Earth Mother and Sun Father, this can fit together. And we hear about Sun Father all the time in church. I mean, he lives in the celestial kingdom, which is represented by the sun. So we know Sun Father. Many of us ache for a deeper connection with Earth Mother. Heavenly Mother. The earth is in the heavens. Copernicus figured that out for us. A few years ago at pilgrimage, I feel like almost everybody had a tree necklace on, and it was almost a little bit embarrassing because we just all were like, yes, I get it, like, that's a thing. So, and I think we were wearing that as a connection to the divine feminine. But I've actually come to see the tree as a representation, as an individual's need for both the feminine and the masculine. The tree needs nutrients from the soil, from Earth Mother, the here and now. But the tree also needs light from Sun Father, the god of yearning for something that is inconceivably far away. The tree needs both of those in order to grow. I see Sun Father and Earth Mother as analogies for different aspects of divinities, of just divinity in general. I see them as part of the same thing, just different parts of the same thing. And then also, if the concept of God is a little bit itchy for you, when I say God, you can think of God as the source of connection and relationship. In physics terms, we would say that that's what gravity and electromagnetism and the strong and weak nuclear forces, that's what they do. They create relationships and connections between matter. So we all know Moses 1:39. This is my work and my glory, to bring to pass the immortality and eternal life of mankind, presumably. That's Sun Father's work. At least that's how I've interpreted that. But if you flip some of the words there, you get a feminine version. Earth Mother's work and glory is to bring to pass mortality and temporal life. Temporal life is a time of darkness, a time of unknowing, a time of growth. In the faraway nearby, Rebecca Solnit says, darkness is generative, and generation, biological and artistic both, requires this amorous engagement with the unknown. This entry into the realm where you do not quite know what you are doing and what will happen next. Ideas emerge from edges and shadows to arrive in the light, and though that's where they may be seen by others, that's not where they are born. I just really like that. At some point, the gender binary thing was not big enough for me. My two older daughters are old enough to go to the temple and do baptism, so I took them. It was my middle one's first time. And I also had to bring my youngest with me. And it was a beautiful day outside. She didn't want to go inside the stake center with all the other kids. She wanted to just stay outside and play games on a blanket under a tree. And at some point, we dissected. There were daylilies all around the temple grounds. We dissected one of the daylilies, and she marveled at the pollen that were on the anthers of the stamen, and and we examined the sticky stigma, and we broke open and looked at the, the ovary and the pistil. Excuse me. And she was amazed that the flowers could be boys and girls at the same time. And I was thinking of my girls inside the temple. The first time my oldest went and did baptisms, she didn't understand until I was explaining to her afterwards that only women can be baptized for women and only men can be baptized for men, and she didn't catch that. She's like, that just seems wrong. We're all people. Well, that's how it is, but and dissecting the daylilies that day, it made me realize that the natural world, God's creations, show us so many other ways of being. So where do God's creations come from? I want to tell you the story of the elements, how we understand that the elements are created. And I'm going to tell you the story of one of my favorite scientists. Her name is Cecilia Payne Gaposchkin, and she was born in England in the year 1900. She loved science from the time she was a very little girl, and she started studying paleobotany. I didn't even know that was a thing, but that sounds really cool. She started studying paleobotany at Cambridge, and there had been a recent solar eclipse, and Arthur Eddington had gone to make observations of this eclipse off the coast of Africa, and Cecilia Payne was super excited to get lecture tickets to this astronomy lecture where he was going to be describing the results of his experiment. These observations confirmed Einstein's brand new theory of general relativity, that mass warps space and time. So this was super exciting, and she, her brain was just like, wow. She goes home and she writes down the whole lecture verbatim, and the next day she goes and changes her major to physics. She ends up restoring the women's college had a telescope that hadn't been used. She starts doing public observation nights with it. She keeps a journal of topics that she wants to study. She is passionate about astronomy. But in England, as she's getting ready to graduate, there are no research jobs available for women in England at the time. The only jobs available were teaching physics to girls at an all-girls school. And she didn't want to do that. She wanted to do research. So she applied to a bunch of grants and scholarships. She ended up moving to Cambridge, Massachusetts, and studying at the Harvard Observatory. And the director there wants her to study, he wants her to measure how bright the stars are. And she's like, I got my own funding, I can do whatever I want. So she decides that she wants to figure out what stars are made out of. So you can separate light into a spectrum using a prism, and this is the spectrum of the sun. And you can see that there's all sorts of dark lines in the spectrum. And different stars have different areas in the spectrum where there's the dark lines. And what she did is she made very careful observations of those dark lines. And they're not completely black, they look black, but it's not completely black. So she was able to take really careful measurements, and those measurements told her that all the stars are mostly made up of hydrogen and helium. And her thesis was published as a book, and this blew people's minds. People just assumed that the stars would have the same proportions of elements as the Earth did. So only hydrogen and helium? What the heck? Her thesis was published as a book, and it helped astronomers figure out how stars shine and what's actually going on inside them. And that elements are actually made inside the core of a star. So we all are familiar with the corona, but on the inside, that's where brand new elements are made. So how do stars make new elements? You start with 2 hydrogen atoms, and the star smushes the 2 nuclei of the hydrogen atoms together, and that makes helium, because now you've got 2 protons. And that reaction gives off a lot of energy, which is the energy that warms up our Earth and allows us to have life. Once all in the middle, once the helium, the hydrogen's all used up, the center of the star starts fusing helium. So now you've got bigger atoms smushed together. You're making larger atoms. And that keeps on going and going and going until, depending on the size of the star, you can get up to like iron, I think. So once, let's see where are my notes. The mass of the star matters. So how big the star is to begin with, that's going to affect the star's lifetime. So our sun in billions of years will probably turn into a white dwarf, whereas a larger star will turn into a neutron star or a black hole. At the end of the life, so at the end of the star's life, it's going to eject those heavy elements that were made in the core and spread them out into space. If you've got a large star that's going to be turning into a neutron star, what happens is that star will explode in a supernova. So this is going to be our nucleus here in the middle, and this is our electron cloud right here. And what happens is in the middle of the star, there's more and more gravitational pressure. So if the electron cloud is usually this big, it's going to get smaller and smaller. It's going to be squished. It's not going to be very, very comfy in it. And eventually, the electron just can't do it anymore. And the electron and the proton will combine to become a neutron. And a neutron's way tinier than this. This is how big the element wants to be, but a neutron is much, much smaller. So when the center of the star collapses and is suddenly teeny tiny, all of the outer stuff is going to fall in too, but then it's going to rebound and explode in a supernova. And that sends those heavy elements out into space, and those heavy elements are recycled to make new stars or rocky planets like Earth. So the Earth that we are standing on right now is recycled old star. The Earth and everything on it is made out of stardust. Now, our sun is mostly hydrogen and helium from the Big Bang, but it also contains heavy elements from a more ancient star, from something that came before. So it's also made out of recycled stardust, just like our Earth. I'm going to make another analogy here. We're kind of like the atoms that are under pressure. Church correlation kind of squeezed women's roles a lot, right, in church. Maybe some excommunications kind of squeezed women a lot. And this pressure is not comfortable. But it is also not bad, because it can be transformative. It might transform us into whatever the equivalent thing of a neutron is. That transformation with that supernova leads to a creative explosion with far-reaching, long-lasting consequences. And I think that the Instagram thing after the Relief Society broadcast, that was a small explosion, and it was exciting because of the mass. So many women were telling their experience directly to the institutional church, and it was exciting because the mass of women doing that helped lead to that explosion there. Now, the sun and the earth, they have very different properties, and and they have different proportions of the elements. But the origins of their heavy elements is the same. I've been saying that the sun is their father and the earth is our mother, and that the sun and the earth both originated from something earlier. As old as the sun and the earth are, it all came from something even more ancient. Sun Father and Earth Mother are also older, from something older and bigger. Father and Mother are just a tiny but crucial part of God. That ancient source that is more than just the earth and sun. So my concept of God includes not just Sun Father and Earth Mother, but also whatever all those other planets, the other stars, the other solar systems, the other galaxies, whatever those might represent to us. And if anything, the study of astronomy has taught us that life seems to be the exception, not the rule in our galaxy, in all of creation, as far as we have been able to figure out. These celestial bodies that we have not deified have inspired curiosity and motivated human innovation. Studying astronomy has fueled so much innovation and technology. We've gone to the moon, Voyagers out there somewhere in space. There's been robots on Mars. We have GPS, we have x-rays and CAT scans and PET scans and MRIs because we've been studying astronomy. Software, lots of software development we have because we are curious and we want to know more about black holes and dark matter and galaxies that are millions of light years away, and exoplanets and the possibility of other life and the origins of the universe. So ancient stars helped to create the sun and the earth. The atoms of the earth constantly rearrange themselves. We're all stardust. I want to read a section from Bill Bryson, The Short History of Nearly Everything. It says, the average species on Earth lasts for only about 4 million years. So if you wish to be around for billions of years, you must be as fickle as the atoms that made you. You must be prepared to change everything about yourself. Shape, size, color, species affiliation, everything. And to do so repeatedly. That's much easier said than done because the process of change is random. To get from protoplasmal primordial atomic globule to sentient, upright, modern human has required you to mutate new traits over and over in a precisely timely manner for an exceedingly long while. So at various periods over the last 3.8 billion years, you have abhorred oxygen and then doted on it, grown fins and limbs and jaunty sails, laid eggs, flicked the air with a forked tongue, been sleek, been furry, lived underground, lived in trees, been as big as a deer and as small as a mouse, and a million things more. The tiniest deviation from any of these evolutionary shifts, and you might now be licking algae from cave walls or lolling walrus-like on some stony shore, or disgorging air through a blowhole on the top of your head before diving 60 feet for a mouthful of delicious sandworms. Like, wow, I don't remember doing all those things. But I am all of those things, and all of those things are me, even though I don't remember them at all. I am the air that dinosaurs breathe. I am the water molecule that hung out at the bottom of the ocean for 1,000 years and then decided to go into my water bottle this morning. I am the dust of the earth. You are the dust of the earth. And this idea makes me feel so small, but also so, so connected to all of creation. I am stardust.